Hello everyone. Today we are going to master one of the most essential skills for your IGCSE mathematics exams, finding the exact values of trigonometric ratios for special angles. Our learning objectives for today include deriving exact values for 0, 30, 45, 60 and 90 degrees, memorizing the hand trick and triangle methods, and finally, solving IGCSE exam-style questions without a calculator. By the end of this lesson, you will be able to state the sine, cosine and tangent of 0, 30, 45, 60 and 90 degrees instantly, and you will know exactly how the examiners like to test this. Let us get started. We begin with the most intuitive way to find the ratios for 30 and 60 degrees, the equilateral triangle. Imagine an equilateral triangle where every side is 2 units long. Because it is equilateral, every interior angle is 60 degrees. Now, let's drop a perpendicular height from the top vertex to the base. This bisects the top angle into two 30-degree angles and splits the base into two segments of 1 unit each. Using Pythagoras' theorem, the height is the square root of 2 squared minus 1 squared, which is the square root of 3. From this right-angled triangle, we can see that sine of 60 is opposite over hypotenuse, giving us root 3 over 2. Cosine of 60 is adjacent over hypotenuse, so 1/2, and tangent of 60 is opposite over adjacent, which is simply root 3. If we look from the 30-degree angle at the top, the opposite side is now 1. So, sine of 30 is 1/2, cosine of 30 is root 3 over 2, and tangent of 30 is 1 over root 3. In exams, you might see 1 over root 3 written as root 3 over 3. These are the same value. Next, let's look at the 45-degree angle. For this, we use an isosceles right-angled triangle. Suppose we have a right-angled triangle where the two shorter sides are both 1 unit long. Since the sides are equal, the two base angles must both be 45 degrees. Using Pythagoras' theorem again, the hypotenuse is the square root of 1 squared plus 1 squared, which equals the square root of 2. Now we can easily define our ratios for 45 degrees. Sine of 45 is opposite over hypotenuse, giving us 1 over root 2. Notice that cosine of 45 is exactly the same, 1 over root 2, because the adjacent and opposite sides are equal. Finally, tangent of 45 is 1 divided by 1, which is simply 1. Just like before, you should recognize that 1 over root 2 is often rationalized to root 2 over 2 in exam papers. Both are mathematically correct. Drawing triangles is great, but in the heat of an exam, you need a way to recall these values in seconds. This is where the finger trick comes in. Hold up your left hand with your palm facing you. Assign your pinky as 0 degrees, your ring finger as 30, your middle as 45, your index as 60, and your thumb as 90. To find the sine of an angle, fold down that finger and count how many fingers are below it. The sine is the square root of those fingers, divided by 2. For sine of 30, fold the ring finger. There is 1 finger below it. The square root of 1 is 1, so sine 30 is 1/2. For sine of 60, fold the index finger. There are 3 fingers below it, so sine 60 is root 3 over 2. For cosine, simply count the fingers above the folded 1. For cosine of 60, there is only 1 finger above the index finger, so cosine 60 is 1/2. This even works for 0 and 90. At 0 degrees, there are no fingers below the pinky, so sine 0 is 0. There are 4 fingers above it, and the square root of 4 is 2, so 2 divided by 2 gives us 1 for cosine 0. Now that we have covered the derivations and shortcuts, let's summarize all the exact values into one master table. You should aim to be able to recreate this table at the start of your non-calculator exam paper. Look at the patterns here to help your memory. Sine starts at 0 and climbs to 1. Cosine does the exact opposite. It starts at 1 and falls to 0. Notice that at 45 degrees, sine and cosine are identical. For tangent, remember that tangent is just sine divided by cosine. 0 divided by 1 is 0. 1/2 divided by root 3 over 2 gives us 1 over root 3. At 90 degrees, we try to divide 1 by 0, which is why tangent of 90 is undefined. The graph has a vertical asymptote there. A very common IGCSE trick is knowing that the sine of an angle is the same as the cosine of its complement. This is why sine 30 equals cosine 60. This summary is your toolkit for the next section, exam questions. In the IGCSE, you won't just be asked to list these values, you will be expected to use them to solve geometric problems or simplify algebraic expressions without a calculator. Our exam objective is to apply exact trig values to find missing lengths and simplify expressions. Let's look at a typical Paper 1 style question. A right-angled triangle has a hypotenuse of 10 centimeters and an angle of 30 degrees. Find the length of the side opposite the 30-degree angle. Show you're working clearly. First, identify which ratio to use. We have the hypotenuse, and we want the opposite side, so we use sine. We write down the formula, sine of 30 degrees equals opposite over hypotenuse. Substituting our values, we get sine of 30 equals x over 10. From our memory, or the hand trick, we know that the sine of 30 is exactly 1/2. So 1/2 equals x over 10. Multiplying both sides by 10, we find that x equals 10 times 1/2. This gives us x equals 5 centimeters. By substituting the exact value, we find that the opposite side is 5 centimeters. In an IGCSE exam, you would get 1 mark for the correct substitution and 1 mark for the final answer. If you used a decimal approximation from a calculator in a non-calculator paper, you would likely lose the method marks. Examiners also love to combine these ratios into algebraic expressions to test if you can manipulate surds, which are square root values. Consider this example. Show that sine of 60 degrees times tangent of 30 degrees plus cosine of 60 degrees equals 1. This looks intimidating, but we just need to replace each term with its exact numerical value. First, we find the values. Sine of 60 is root 3 over 2, tangent of 30 is 1 over root 3, and cosine of 60 is 1/2. Now, let's substitute these into the expression. Look at the multiplication part. We have a root 3 in the numerator and a root 3 in the denominator. They cancel each other out perfectly. So, the expression simplifies to 1/2 plus 1/2, which equals 1. We have shown that the left-hand side equals the right-hand side. This type of question is very common in the higher tier papers. The key is to keep your work organized and not to rush the fraction multiplication. Thanks for watching. Finally, let's look at a question involving the area of a non-right-angled triangle. This often appears toward the end of the IGCSE paper. Triangle ABC has side AB equal to 6 centimeters, side AC equal to 4 centimeters, and angle BAC is 60 degrees. Calculate the area of the triangle and give your answer in the form of root B. To find the area of a triangle when we know two sides, and the included angle, we use the formula area equals 1/2, AB sine C. Substituting our values, the area equals 1/2 times 6 times 4 times sine 60. Now, we substitute our exact value for sine 60. Remember that sine 60 degrees is exactly square root of 3 over 2. 12 multiplied by root 3 over 2 is the same as 12 divided by 2, then multiplied by root 3. This simplifies to 6 root 3 square centimeters. The question asked for the answer in the form a root b, and we have achieved that. Notice how much cleaner this is than a long decimal. It is exact, precise, and exactly what the examiners are looking for. We have covered a lot of ground today, from the geometric origins of these special values to their application in IGCSE exam questions. To recap, first, the equilateral triangle gives us the values for 30 and 60 degrees. Second, the isosceles right triangle gives us 45 degrees. Third, remember that the hand trick is your best friend for quick recall. And finally, these exact values are essential for your non-calculator exam papers. Remember, the IGCSE examiners are testing two things: your ability to recall these values and your skill in manipulating fractions and surds once you have substituted them. Here is a practice tip. Try to derive the entire table from memory once a day for a week. You'll never forget it. Take a moment to review the summary table we built earlier. If you can recreate that table, you have unlocked a significant number of marks in your upcoming exams. Goal met, you can now find exact trig values and solve related exam questions. Keep practicing these derivations and worked examples. Well done on completing this lesson, and good luck with your revision.